Welcome to Chapter 3. Chapter 3 is going to discuss atoms in the periodic table. We're going to get into the different elements on there, the different categories, how it's organized, and how to read each thing. So we're going to start off by discussing what atoms are. Atoms are all the little particles that make up the elements. So one atom is technically an element. You could go the same way. But elements can be a bunch of atoms as well, but they are made up of individual atoms. So, what are atoms? Atoms consist of three different particles. Those are protons, neutrons, and electrons. Protons have a positive charge, neutrons have a neutral charge, and electrons have a negative charge. Going back, just so you know, these things are broken down even further, the proton and neutron at least, into quarks. So a proton is two up quarks and a down quark, and a neutron is one up quark and two down quarks. But just so you know that our definition of atom from the book is indivisible, and that's what we thought at the beginning, but now we can't actually break up atoms into protons, neutrons, and electrons. We can even break up protons and neutrons into different things as well. Your structure of your atom has changed throughout time, but it's pretty much basically been the same for the past 50 so years. So this is what your atom looks like, the best we can depict on a two-dimensional scale here. But we do have a nucleus to your atom. Your nucleus is located right in the center. It is made up of neutrons and protons. They are held together by a force called the strong nuclear force that holds them together so they don't fly away, which makes it really hard for us to lose protons and neutrons. Electrons, on the other hand, orbit around this nucleus in a cloud. So they are located in this fuzzy region around here, and they are in constant motion, and it is very easy to lose electrons. It is also easy to gain electrons. Here is Bohr's model of carbon. Just so you know, I am going to be using this for a few references, but you will note carbon has an atomic number of 6, meaning 6 protons. Obviously it's three-dimensional, so you can't see all of them there. Some are in the back, but you can see the 6 electrons of it. But you still see the nucleus, and you still see these orbitals, or the electron cloud. This electron cloud, right, is where all these electrons are moving around. It's a spherical region around your nucleus. If you have less energy, or if you're moving slower as an electron, you're going to be closer to the nucleus. If you have more energy, you have the ability to go further distances. The mass of atoms, because atoms are matter, therefore they do take up space and have mass. Electrons will take up the most volume, even though they are the smallest of the particles. They take up the most volume because they move around constantly, so all the area that they are moving in is also considered part of their volume. However, because they do have the smaller particles, they do have less mass, so their mass is about 1/2000th of a mass unit. And we are going to measure things in atomic mass units due to the scale is just extremely small, and we can't use grams or kilograms. So they are AMUs, or atomic mass units. When compared to your proton and neutron, your electron, again, is extremely small. Your book is going to go into the analogy of an elephant versus a cat. You can think of the protons and the neutrons as elephants, having one atomic mass unit each, and the electron being extremely small in mass-wise, having 1/2000th of electron. Or in other words, it takes 2,000 electrons to have the same mass as one proton. Our next section is going to get a little more in-depth in atoms, so it is just part 2.